Let's talk, in this lecture, let's talk about the Basquin equation. The Basquin equation is an equation that basically relates your fatigue strength to your number of life cycles. Is basically S is equal to A times N over B. That's the most general form of this equation. And how do we handle this equation is very easy because your A, remember this is a log-log plot. So if I want to solve for B, if I wanted to solve for A, right, I could say that A is going to equal to S divided by N over B, right? If I had B, I could do this. Now, I could also do this. If I want to find B, I could actually take the log on one side, take the log on the right-hand side, and this will equal to uh, log A plus B times log N. And then I can subtract this. This is log S minus log A divided by log N is equal to B, or simply this is going to equal to log S divided by A divided by log times N. That would be a B. So if you knew your A, you knew all this, you can find your B like this. Now, when we're going to plot, for plotting purposes, right, uh, what we typically have is we have two S, S1, S2, and this S, they're the same plot, same material. So this will be N1, N2 over B. Okay, and then from here, what I could do is I could divide these two and say S1 divided by S2 is going to equal to A1 over B, A and 2 over B, and I can cancel A, and that will give me N1 divided by N2 to the Bth power. So I can take log on both sides now. And if I take log on both sides, if I take log, S1 divided by S2 will actually equal to B times log of N1 divided by N2. So now I could solve for B, and then B is equal to log of S1. Let me move this here. S1 divided by S2 divided by log N1 divided by N2. Doesn't matter how you do this, you can flip it, but if you flip it, there's just a minus sign and there's another minus sign there. So you could do it either way and should give you exactly the same answer. N2, N1. So if I had my B, then I can just use this equation to find my A, right? Then I could say A is equal to any of these, and I could say S1, let's say, divided by N1 over B. So that's how you will find the values of A and B. Now, for plotting purposes, you will have several plots, right? For the traditional plot, you will do something like this, and you want to do from first segment is segment number 1. And then for segment number 1, you would say S1 is equal to SUT. Segment number 2 is equal to SF. Segment number 2, that is this segment, S1 is equal to SF. S2 will be SE or SN, depending on the case. And from here, you will find that A and B, That's called A1, B1. Um, and then from here, you will find A2, B2. Okay? And remember that this is just this. So these are the different values. This is SF, this is SUT, this is SE. Now and this is number 2. And for for the conservative approach, what we do is we have a SUT, and then we have SE or SN, which is to a straight line, right? So, this is a traditional approach. This is a conservative approach. Let's call this number 3. For number 3, then S1 will be SUT, S2 will be SE or SN, depending on the case. And from here, you can find an A3 and a B3. Okay, so this is how you actually handle these treatments for these equations. And that's how we use the Basquin equation.